Welcome in. Today I'm going to have a simple comparison between a thread and a task. Many people might think a thread and task are just the same, but there are some subtle differences. For those who don't know me, I am an online trainer on .NET. I've been training since 2 decades. So if any of you want to go for a one-to-one sessions with me, classes with me, you can definitely contact me. The description of what will be given in the description box below. So let's get started. Let me create a new console application. Click next. All right. I'm using the .NET Core console application, by the way. Let me let me name this as thread versus task, right? And click next. We are going to be going for this .NET 8 because it's already in release. I'm going to be having those settings. Do not use top level statements. That means we should be having public static void main. Well, to start with, for those who exactly don't know what a thread is an execution unit which can run your code, right? That's it, very simple. Even if you don't write a bit of thread in here, you already have some threading. If an application starts, it will already have some thread. And the thread, we call it as main thread or the mother thread. So when this application starts, it always starts in its own thread. And that's the principal thread, or you can call the mother thread, right? So even if you write nothing about thread, it's still the application is threaded, right? It's a single threaded application. Now let's say I'm having another function, static void, okay, like write numbers, okay, kind of function. Now this function is going to be writing some numbers on screen, and let us do that. I'm just going to be writing 1 to 10, and I'm going to type in console.writeLine I can start from 0 or start from 1, whatever you want, right? It's a very simple one. So I'm starting from 1, going all up to 10, and it will write numbers on screen one after another. To just spice up the thing a little bit, we will be using some thread.sleep. That's the way we can a little bit emulate delay in our application. So we'd like to delay for 1000 millisecond, that is 1 second in every iteration. Now we need to be calling this function. Till now there is no threading. So I'm just going to call this function. Since the main is static, we can only call statics from a static function. Probably you already know that. So we have a static keyword for this function. If we had like void numbers, then we have to be creating an object, a program, and then call on this method. They are the pretty basics about object orientation. Hoping you already know this when you have come to this video to watch this illustration. So now if I run this, you will notice that it first starts off with writing hello world, which I haven't deleted so far. So it's compiling, and then 1, 2, 3 things are coming up, right? It will go all up to 9 and 10, and you won't see 10 because after that the console will, yeah, you will still see, because .NET Core like this console holds the output. It don't closes the console, right? It's good. So you can see all up to 1 to 10. Now, while this is happening, we cannot do anything below. In fact, it is frozen. The main application is frozen because this function is actually executed by the main thread. Once again, since this call was from the main function, so this entire code is being executed from the main thread. Now, how about we can actually get this into another thread? I mean, we want the main thread to be free. We want the main thread just to call this function, but not wait for it. We don't want this main thread to wait. You know, the way we do this is very simple. We do this by creating a thread class, thread t equals to new thread. And then we will be we will be passing in the name of this function right here, which is write numbers. All right, write numbers, and that's it. Write numbers, and then we will start the process. T dot start. So I'm going to be commenting this. So T dot start is going to start the thread. Is going to start the application. Is going to start it. All right. But let's watch out what happens when I now run this. It writes it all through, right? It will write all up to 10. It's over, right? But let me confirm you about one thing, that the thread that you see is actually a foreground thread. Yes, it's a foreground thread. Let me do one small thing. At this point of time, can we exit out of the application? Is it possible to exit out? So we can write console.writeLine, and we can say that press any key to exit. We can really exit out of this application because the application is running on a different thread. Let me run this, and you can see press any key to exit has already been printed, right? So that means technically it will wait for my console.read key. Console.read a key will wait until I hit a key, and that will stop the application. In fact, the application was already stopped. You didn't notice it. It all because this .NET, this window, there's a setting up here. It says every time. So let it go first. You see, press any key to exit. So that means the application is now waiting for this exit call. By the time by the time you actually see this text, that means your application is already dead. It's already dead. Only a dead application will show up this text. We will actually stop this text from coming up by going to Tools, Options, Debugging, and automatically close the console when the debugging stops. We are going to be disabling this, okay? We are going to be enabling this again, of course, to automatically close the window. We want this Tools, Options, Debugging, automatically close window on exit. So we got Tools, Options, Debugging, Tools, Options, Debugging, where we go, Debugging, Tools, Options, Debugging, yeah, Options, Tools, Options, should be down somewhere. I'm poor at finding things, Tools, Options. Oh my gosh, when I'm finding it. Tools, once again, is Tools, Options, Debugging, of course. Oh, we got the options. Now going to be getting into debugging. Tools, Options, Debugging, and then you have to go to automatically close window when the debugging stops. So we have an option here, automatically close window when the debugging stops. So there should be some option right there. Automatically close window. Yeah, we need to just check this on, right? Automatically close window, close the console when the debugging stops. Remember that. Options, debugging, automatically close the window when debugging stops. I always enable this. For some reason, it got enabled back. Probably I have reinstalled Visual Studio a few days back. So now look at this. One, these are coming because the main thread is, the child thread is running and the main thread is still alive. Okay, and then after this, you can see press any key to exit. Why this has come in the top? It's because the child thread and the main thread is executing parallelly. In fact, that is what thread is all about, right? So this is why you can see the text right here. And now if I hit enter, the thing closes. So that means once after kicking start this particular thread, press any key to exit came straight at you, and you can close it at any moment. I can show you this. Let me hit enter at this moment, and As you do this, you see, as you do this, the terminal don't close. To our surprise, the terminal don't close. Now, why is that really so? It is so because by default, the threads that execute are foreground in nature. That is the thing I want to stress on. The thread, any thread created by this is a foreground in nature. What I'm going to do is that I'm just going to be turning this thread to a background thread, just making it a background. And now watch out again. Well, the background thread is producing this data, but the main is already on its way. It has already in the end. Now, okay, let it go because while talking, it's already countdown to 10. Let me start over again, and I'll hit any key right here, and that closes. That closes. Why? Why did it close immediately? Because when you hit some key, the main thread got closed. And whenever the main thread gets terminated, any of the background running threads will be terminated immediately. This is quite the reason why you saw the screen going off, the program shutting down, right? When the main thread is dead, and automatically all the threads are dead because the background thread will be killed immediately, and so the application is stopped, is complete, is shattered, stopped, But if any one of the thread kept running, the application will still run and the console won't close. And that is the case when you either write background to false, that means it's a foreground thread. Foreground threads enjoy much more allocation and much more seniority with the main thread. Now, if I hit enter, nothing closes. I have already hit enter, it didn't close. It only closes once the child thread has finished its job. So this child thread is actually now no more a background, it's a foreground thread. So in a sense, if you create a thread, by default it's a foreground. You have the ability to change it to background by turning this thread's properties background to false. So that was a little description of how can you work with this, how can you call a function using a thread, and also how to make it go background so that when the main thread stops, that background thread will automatically stop itself. Now, the next point, how do I do the same thing using a task? So I'm going to be copying this whole thing. I'm going to be commenting this whole thing. That's fine. I'm going to be creating this static void main again. And now the same description, but using, I missed copying T, S, okay. And then console.read key. I will have these two lines intact. All right. Now watch out. I'm going to be writing task. Task T equals to new task. And if you watch out for the argument of the task, it is asking for some action delegate. Now an action delegate, if you click on this action delegate, okay, if you just say action, okay, if you right click on it, okay, action, I right click and go to the definition of it. An action delegate is just a delegate with no input, no output. It's both void as an input and void as an output. So the same thing is our function as of now. Write numbers, don't accept anything, don't return anything. So what I can do is that I can just write, I can just call this right, I can just pass in this write numbers just the way we are passed thread write numbers, the same way. All right. And next you need to be starting this. All right. You started this task. When you started this task, it's same as starting the thread. You see, there's no difference. You just have thread T and task T. You started this task. Now, when the when this particular task already starts, we will see what happens. Does that starts the countdown? If it starts the countdown, then does this text print on the screen? If it prints, of course, it's waiting. The main is waiting for the read key. If I hit enter, is it closing? If it closes immediately, you can guess that this task thread runs as a background. If it doesn't close the window, you'll understand the task thread is actually foreground. So let me run this at this point. So you can practically see no difference. Let me quickly hit enter and it stops. Great. So you understood that that the task-based threads are actually background threads and not foreground threads. So whenever we create a task, they always run in background. You see no visible, not much of change, I mean differences from that of writing thread T, new thread, the function, and then calling the start, and then task T, new task, the function, and then calling the start method. However, the task gives you more flexibility. You just don't want to touch these lines only until you finish the thread. So you might want to wait for this thread to finish its job. But in the thread, you see, you just kickstart this start and you proceed with the rest of the execution. You might argue that is what threads are basically designed for, concurrent execution. I know it. Many of you might think that way. But let me tell you, sometimes we want concurrency in the action, but we don't want the main thread to, we might want the concurrency, of course, not a problem, but we'd also want the main thread to remain free. That is the reason we use task for. The main thread should not be tied with another job immediately upon, this guy has been kickstarted. We want the main thread to be remaining free so that other user interactions can follow. Okay, so we don't want these two lines to come up immediately after starting this task. For that to be done, we just need to write await t, right? Await t. In that way, you will not come up to these lines only until this thread has finished. I'll dedicate another class for it. In fact, I already have a video for it. You can watch out. I'll spend one more video for this, of course. But awaiting T means you don't want this. You don't want the control to go past this line only until the thread which was running completes its task. To have an await, you must give a async keyword to the function that has that in, and that's it. That's quite it. That's quite it. So now if I run this, you will watch out. Oh, there's a mistake. Program doesn't have static void main. It's just because if we have an async, then instead of writing void, please write task, and that's it. If I run it now, you see the same thing coming up, and don't press any key to exit only until the countdown reaches 10. Here we go, right? So now it is waiting for this. This is great. This is really awesome, right? So I hope that you understood the point that the differences between the principal difference between a thread and a task is that a thread runs by default, a thread will run as foreground. By default, a task will run as background. So on exit of an application, which actually means exiting out of the main thread, will automatically shut down all the running tasks. It will shut down because they are running in background. But that won't be the case for threads. We explicitly need to tell them to shut down, right? Otherwise, they won't shut down. But tasks will automatically shut down. But there are ways to instruct the task that something is closing. So there are ways to notify that this task too. But that's again the topic of another discussion. The how exactly we can notify those tasks that the main thread or the main application is shutting. So you kindly stop whatever you are doing, right? We don't want to disturb any work that is happening in the middle. So stopping a task immediately can cause some undesirable effects. So it will be always good to communicate with the task and saying that you please stop your job because we are shutting down, right? But otherwise, if you don't want that behavior, if you're fine with stopping at any moment, you can do that, because when the main thread stops, all the tasks that are running will stop immediately. I hope that has created some value, some importance. You understood a little bit of more of the difference between thread and task. Let me know if you got any questions in the comment box. I'll do my best to answer them. Thank you so much for your time.